Okay, number 5, I've got a function given. The first question is find the slope of the line tangent to the graph at x equals 3. I need to know f of 3. I also need to know f prime of 3. Let's find a derivative formula first. That's going to be, since this is a 1 over x kind of function, I'm going to do negative 3 over the denominator squared, 2x squared minus 7x plus 5. Timed, because of the chain rule, 4x minus 7. And so f prime of 3 I can figure out from that. Okay, let's go back to f of 3. When I plug 3 into this, I'm going to get 18 minus 21 plus 5. So that's 3 over 2. And when I plug in 3 to the derivative, I'm going to get negative 3 over, that denominator is going to be 2, but this time I'm going to have it 2 squared. And then I'm also multiplying by 3 plugged into this, which is 5. So that looks like it's going to be negative 15 fourths. And actually, I don't actually have to find f of 3 because all it's asking for is the slope, not the equation. So negative 15 fourths is the slope of our tangent line. All right, for part B, it says the x-coordinate of each critical point on the interval from 1 to 2.5. So if we take a minute for this function and we think about the places where the bottom equals 0, this is a quadratic that can be factored. 2x and x, I believe it's going to be minus 5 and minus 1. That gives me all I want. 5 halves and 1. So not only is that two values where the function doesn't exist, but it's also our interval, right? So it's basically saying between these two values, are there any other critical numbers? So I want to go back to my derivative formula. Let's do that again. That was negative 3 over the denominator squared and times 4x minus 7. So I already realized that the zeros of the denominator are these two numbers, but I want to be within that interval. And so I want to think about any other critical points. If I set the numerator equal to 0, I get x equals 7 fourths. So 7 fourths is going to be on that interval from 1 to 5 halves. 7 fourths is almost 2, right? Somewhere like that. And it asks us, is it a relative max min or neither? So I want to think about the value of this derivative on these intervals. I know at 7 fourths it's going to be 0. So let's pick a convenient number a little bit more than 1, but less than 7 fourths. Let's do, I don't know, 1.5. So if I plug 1.5 in here, I get 6 minus 7. That's definitely negative. Negative times a negative is a positive. The denominator is always positive, so that's going to be a plus. And then something like 2, which is going to be on this interval, would give me 8 minus 7, which is positive, times a negative, so that's going to be negative. Remember, you can't just do the sign chart. I have to summarize it. So x equals 7 fourths is a relative max because f prime goes from positive to negative at 7 fourths. Something along those lines. You could say also that between 1 and 7 fourths the derivative is positive, and between 7 fourths and 5 halves the derivative is negative. All right, C gives us the fact that I can write the function as partial fractions. So this is a partial fractions problem, but they did the hard work for you. So it's already broken apart. We already know our expression, and so I just have to integrate that from 5 to infinity. So remember that with infinity, I actually have to change that into a limit problem. So I want the limit as b approaches infinity of the integral of the expression from 5 to b. And evaluate that and do the limit at the end. So This is going to be natural log of 2x minus 5. I do have to think about the fact that this has a derivative of 2, but that takes care of itself, and you could check by differentiation, but that's the exact antiderivative. This one's going to be minus natural log of x minus 1. I have two logs that are subtracted. This is a good time to put them together. And so I get this with my properties of logarithms. I want to evaluate that from 5 to b, and then take the limit as b goes to infinity. And that's going to be the natural log of 2b minus 5 over b minus 1 minus the natural log of, this is going to be 5 fourths, right? As b goes to infinity, this expression here is going to go to 2, so I end up with log 2 minus log 5 fourths. And if you want to, you can put those together and say log of 2 over 5 fourths, which is natural log of 8 fifths. So this is a convergent integral, and it converges to this value. All right, part C. This is a test for convergence. There's probably a couple different tests here you can use, but I would hope you might think of a limit comparison test. So if I take the limit as n goes to infinity of a close by function, so I'm going to use 1 over n squared, and divide that by 3 over 2n squared minus 7n plus 5. If that's constant, then that means that this and this would behave the same. So when I simplify this, I get 2n squared minus 7n plus 5 over 3n squared. And that limit as n goes to infinity is 2/3. So the fact that that limit is a constant means that these two expressions are going to either both converge or both diverges. We know that the limit as n goes to infinity of 1 over n squared is convergent because it's a p-series where p is greater than 1. And so that means that our initial series, 3 over 2n squared minus 7n plus 5, also converges. I could probably use the integral test, a few other tests here, but limit comparison works pretty well.